Hello and good afternoon. A warm welcome to this short episode on the Powertek product CTA3PH. In this episode, we're going to talk about some of the pitfalls of measuring currents, particularly where the waveforms that you think you're measuring are actually more complex than they first appear. So just a quick summary. The CTA3PH product has this current measuring hoop. It's called a Rogalski coil, and it measures currents from 100 amps up to several thousand amps, and you can put this current sense Rogalski coil around the conductor pretty quickly, minimizing your shutdown times, and then there'll be a signal conditioner with something like that inside of it, which would change it back to 5 amps, making it compatible with legacy metering meters and smart meters and the like. And many of those are 0 to 5 amp inputs. So this episode is really looking at the complexities of current. So the question is always, which one should I choose? For example, should it be 5,000 amps? Should it be 4,000 amps? And many people make the mistake of actually trying to size this product very close to the maximum current they'll see. And that's because they're concerned about accuracy. So it's a valid thing. But what they don't realize is these Rogalski coils are basically designed and configured in such a way that we can measure down to 1/100th of range, which is something a conventional CT simply won't do. A conventional CT will measure perhaps from 10% to 125% of range. Many people will not operate it even down to 10% because you're already seeing phase errors, amplitude errors coming in. These things don't do that because the electronics we supply keep them extremely linear. And I have a Rogalski coil in this lab that measures 300 amps peak, and I will measure 1 amp down to, say for example, the power frequency is 100 hertz, and I'll expect to get 1 amp plus or minus 1%, and that is in a 300 amp Rogalski coil. So it's a phenomenal technology, and if they're designed and constructed the right way, the linearity and the dynamic range is fantastic. So what does that mean? Let's go back to the original kind of question, is if we were measuring 5,000 amps, and it turns out that 5,000 amps RMS currently that you're trying to measure may actually have current peaks in there of, say, 10,000 amps. So they might have a very large crest factor. The crest factor is the ratio of the RMS to the peak of the waveform, and you really need to be cognizant of what is going on. So with any signal or any kind of utility measurement that you're going to perform retrospectively, and by that I mean putting in a metering system to see what the latest usage is in a particular area. It could be a shopping centre, a hospital, or something like that. You really want to do due diligence and just check the wave shapes that appear there typically. And we're not talking necessarily harmonics. I mean, clearly these waveforms are harmonically distorted, but as far as using the correct Rogalski, you need to know not just the RMS, but what is the repetitive peak current. So typically, if you were wanting to, say, measure 5,000 amps, you might want to select a 10,000 amp current sensor. And there's hardly any discernible degradation between those two ranges. And at the same time now, you're able to measure currents which are distorted, which you're bound to get in this day and age, because with all the PC computers, motor drives, lighting ballasts, all drawing very non-sinusoidal currents. And that means that you need a little bit of headroom to ensure that you catch that repetitive peak as well as the RMS. And so there's no scientific reason to pick something that's right close to the normal RMS running current when you can maybe go 2 or 3 times that, allowing that headroom. And the kind of equipment we see regularly, this active power factor correction equipment, where they want to measure the actual currents in the building, and then when they know what it looks like, they can compare it to reference and then inject harmonics which cancel the harmonics. So it's like a form of current shaping. This Rogalski coil system that we have is ideal to do that. But this is really just giving you an introduction into some of the things to be mindful of when you are buying the CTA3PH from Powertek. Just ask yourself that question: do I know what the waveforms look like? And what it really boils down to, you can attach this thing around the conductor and just pop this into the integrator, the signal conditioner, and physically look at the current wave shapes and at least sort out what the repetitive peaks are. Because generally most people are wrong when they are looking at their conductors. They're not actually aware of what the peak current could be. And bear in mind that loads in the last 10 years have become more complex, so things have been changing. So once again, I hope that's quite helpful. Reach out to us anytime on this subject. If you're installing a CTA3PH, it's probably a good idea you carry out some of the things I've suggested, or reach out to us. And the UK telephone number is 01788 519911. If you're in the US, it's 1-631 384 3481. And of course, email is a good way of doing it. It would be info@powertekuk.com or info@powertekus.com. Feel free to reach out. My name's Derek Luce, and we'll do our best to get you up and running. Thank you.